This video is about physical versus chemical change, which is covered in Pearson Year 8, Chapter 7. We're going to start with physical change. Now, the key thing of this is that no new substances are formed. The same substance is still there, it's just slightly different. And the other key information is that these changes are often reversible. Let's start looking at what I mean by different. What can be different is the shape can be different, the size of this object can change, or the state of matter. We are going to look at these individually in a moment. Another example of physical change is mixing two substances together to form a mixture. Remember when we did mixtures, we looked at the idea there were no chemical bonds between the two substances. We'll start with change of shape. That means something, for example, like a scrunched up piece of paper or a crushed aluminium can. They're still paper, they're still the aluminium can, their shape is just different. You could reverse these by smoothing out the paper, for example. Change of size can be as obvious as ripping a piece of paper in two, but can also be due to expansion or contraction due to heating or cooling. An example of this is a thermometer. The liquid inside the thermometer expands up the tube as it heats, so the temperature recording is higher, or it contracts down the tube when it cools down, so the temperature recording is lower. Changing states of matter we've done. For example, melting is solid to liquid, like the ice is melting into liquid water. What I'd like you to do now is to pause the video and write down all the other changes of states of matter that you know. One of them should be evaporation, such as when water boils, it turns into steam, which is gaseous water. Another one is condensation, when gas condenses into a liquid when it cools down, such as when the moisture in the air condenses to liquid droplets on a cold Coke can or on a mirror, for example. Another is freezing or solidification, where liquid turns into a solid, such as liquid water turns into ice when you freeze it. The last two are sublimation, when a solid turns directly into a gas when you heat it, such as in the diagram, the grey iodine solid, when it's heated, turns into a purple gas. When that gas cools down, it turns back into the grey iodine solid crystals, which is called deposition. The last example of physical change we're going to look at is when you mix different substances together to make a mixture. For example, if you dissolve salt in water, it makes salt water. You've still got salt, you've still got water. This is reversible, as you know, you could evaporate the water to remove the water, leaving just the salt behind. So it's a physical change. Chemical changes are different to physical in that new substances are made in a chemical reaction, and they're usually irreversible, which means once you change them, you can't change them back. So how can you tell visually if a change is chemical or physical? There are 4 changes that may occur, which says it's a chemical change. Now they are: number 1 is a permanent colour change, such as when leaves change their colour in autumn or dyeing your hair. Another sign a chemical change has happened is a gas is produced. Now you might smell this, such as the smell of rotting egg gas when something's rotting, or bubbles are made in a chemical reaction. Now the first picture is of a piece of magnesium and hydrochloric acid that's producing hydrogen gas, or bubbles of it. The second picture is of the volcano experiment, which you've all probably done before, mixing vinegar and bicarb together, making bubbles of carbon dioxide. Be careful when using bubbles alone as an observation for chemical change. For example, boiling water has lots of bubbles, but it's a physical change because you're just turning a liquid into a gas. Bubbles in a chemical reaction will be observed with one of the other signs of a chemical change. The third one's called precipitation. In chemistry, no, we don't mean rain. We mean a solid precipitate has formed. Now, what is a precipitate? It's a solid that's formed when two clear solutions are mixed and it all goes cloudy. As you can see from these two pictures, there were two clear solutions, one still inside of the pipette, but when they're mixed together, you either get a bright yellow one, which is called lead iodide, or the white one in this case is called silver chloride. But if it goes cloudy and they were both clear before, it's a sign of a chemical reaction. The fourth sign of a chemical reaction is energy change. Now, one sign of that can be light given off, such as fireworks, or any kind of a flame is always due to a chemical reaction, or even something like glow sticks where you have to snap them in order for them to glow. When you snap them, you mix the two chemicals together inside of the glow stick, which makes it glow. It can also be a temperature change. Now, what we mean by this is not you heating it up or you cooling it down, but the chemical reaction itself changes the temperature. Now, if it feels hot, we call this an exothermic reaction. Thermic meaning heat, such as thermal energy, and exo meaning outside, such as an exoskeleton is on the outside of an insect. Now, some examples of exothermic reactions are combustion, such as making the flame you can see above, or even something like a hot pack. Not like the ones you heat up in the microwave, but the instant ones where you have to, in this picture here, it says squeeze the outer edges towards the centre. What you're doing is you're cracking open a little container thing inside, mixing those two chemicals together, which make heat in an exothermic chemical reaction. Conversely, if it starts to feel cold after a chemical reaction, we call this endothermic. Endo meaning inside, so all of the heat from the outside is going into this reaction, making the whole thing actually feel cold. An example of this is an instant cold pack, which is the opposite to an instant hot pack. In this case, the chemical reaction's making the whole thing feel cold. Now that you've learnt about physical and chemical change, can you actually spot them? I'm going to give you some examples. I want you to write down the examples and whether you think they're physical or chemical change and why. The first example is melting chocolate. Have a go. Hopefully you said physical change. The reason being it's a change of state from a solid to a liquid. You still have chocolate, it's just liquid chocolate. Quite delicious looking too. If you put it in the fridge, it would then solidify back into solid chocolate. So it's reversible. While we're on a cooking theme, the second example is frying an egg. Is that chemical or physical? Hopefully you said chemical change. Why? Because you've got a permanent colour change. The white goes from clear to white when you cook it, and it's very much irreversible. If you cool down that fried egg, it won't go back into a raw egg again. And in fact, as a hint, all cooking involves chemical reactions. Unless you're freezing something or melting something in cooking, everything you do is a chemical reaction. Why? Because they're all irreversible. For example, if you cook a piece of meat and you cool it down, it doesn't turn back into raw meat again. You cook a piece of bread into toast, you cool it down, you've just got cold toast. You don't have the bread again. The third example is if you set a piece of wood on fire, i.e. burning wood. Is that a chemical change or a physical change? Hopefully you said chemical change. Why? Light's given off in the form of the flame. You have a permanent colour change of the wood. It goes from brown to black, and then when you cool it down, it actually, you see like the white or grey ash, and heat energy is given off. So this is an example of an exothermic reaction. The fourth example is mixing magnesium with oxygen in the presence of heat to make magnesium oxide. I want you to watch the following video and decide if this is a chemical or physical change, and if you think it's physical, why? If you think it's chemical, why? Hopefully you decided this was a chemical change. One, a new substance was formed in the form of magnesium oxide, whereas before it was magnesium and oxygen. The oxygen is coming from the air, by the way. Light's given off, that really bright white light. It also gets really hot, so heat energy is given off. And you have a permanent colour change because the magnesium oxide is a white powder, whereas the piece of magnesium was a grey strip of metal. Well, hopefully now you've learnt all about physical and chemical change and you can tell the differences between them.